Okay, so welcome back everyone, and let us continue with today's problem of the day, which is nothing but zigzag traversal of a tree. So day before yesterday, we solved this one problem, that is to convert binary tree from in order and post order. And there goes a DSA repository having 500 plus days of code, 500 plus solution. Do start and fork to get help with your interview preparation, right? There's some changes on our YouTube channel. So whatever day it is, like today is 10th October, right? And we'll be covering 500. I don't know which day it is, right? So that would be featuring in our main channel like this, so that you can just come onto the channel and get help straight away, right? You don't have to search the terms on the YouTube. So let's get started with today's question. So given the root of the binary tree, you have to find the zigzag traversal of a binary tree. In the zigzag traversal, it means that first level you go from left to right, and then the second level it go from right to left, and for third and fourth you go on the vice versa, right? So left to right, then right to left, again left to right, and then again right to left, right? So let us switch back to our tab screen. I will see that how many ways are there to solve this. So can okay. This video will be covered in three parts: understanding the question, the dry run of some problems, one problem basically, in which the intuition will be discussed, and the third would be the code, like coding, right? ठीक है. तो हमें करना क्या है यार? Okay. One thing कि if you are solving a tree question for the first time and you have direct jump onto the zigzag traversal code, so do not do so, yaar. We have maintained a playlist for bunch of other DSA topics. You can just come back to our channel again. Go to A to Z topic wise. You will have a list of binary tree here. There are basically 40 videos, but must cover the top 10 videos and you'll be able to get through it. At least you'll have the basic understanding. You'll be covering basic to intermediate DSA questions, right? So let's come back to our screen again. So what it says is that there's been a root node, one, and then two, and then three. This is four, this is five, six, and seven, right? We need to print the in the zigzag way. So I think the expected output is already clear. So in the first level, you go from left to right, and the second level go from this to this, and then in this direction. If you'll print the nodes in this direction, you'll get one, three, two. And for this level, you'll get four, five, six, and seven. What to do now? Now, there's been an order maintained, right? So to maintain an order while we are popping out from some data structure, what is the data structure we use? Either we use queue or either we use stack, right? So stack maintains LIFO and queue maintains FIFO, right? So let us go ahead with the stack here, and we will maintain basically two stack, right? S1 and S2. And let's say we have pushed the first root node one into our S1, right? So till our S1 or S2 have any elements, we will be processing our entire process, right? So we will have one, say, let's say one array list or array, whatever be the return type given in the question. So we pop out from the S1 and we add it in the array list. Now we need to understand now what is the actual ask here. When I go to the second level, I need to process the nodes like this. Like first three should be printed and then two, right? And stack maintains LIFO. So what if I push the last element at the uh, position, right? Which position basically? Basically the last element in the first position, right? So what I'm going to do is I want three as my first this thing output for this particular range, 3, 2, right? So I'm gonna process the next element first, that is 2, which is nothing but our left child. So I'm gonna say for S2, I'm gonna process left first and then right first. So remember this thing left and right, it will be handy when you will try to code it. So we process the left children first and then we process the right children, right? So we have second level covered. Now we don't have an element from S1. Now we go on to the another stack and we check, okay, S2 has some elements, so let's pop it out. So we pop the first element, right? And here goes our three, right? So it matches here. Now for three, the elements are six and seven, right? And what is the order we need? We need six and seven, right? So we gonna process for S1 as first we push the right children and then we push the left child. Doing so, if you push the right children first, it will give you 7 here and then 6, right? And then it until our S2 elements are not over yet, right? So we process the next element, which is 2. We add it in our array list, and you can see the order has been remained same as our expected output. And since we have processed the element which is 2 from S2, and in the S1 we decided to put the elements in the order as right and left. So the right child of 2 is 4. So we're going to push 4 here, and the left, okay, right child is 5 basically, and the left child is basic nothing but 4, right? And there goes our S2. Now S2 is empty. We again go on and we see that if either of the stack has element or not, right? So I can see S1 has some element left, right? So we're going to start processing those. So 4 has no children, so just pop it out and nothing to add in S1. 5 again has no children, pop it out, add in the array list, nothing to process in S2, and 6 and 7 the same, right? So you can clearly see we have obtained our expected output as given, right? Please pause this video here right now and try to code this approach by yourself, and then we'll start with the live coding. But before going ahead, what would be the time and space for this one? Time would, I can say, O of n, right? Because we are visiting each and every node of the tree, and space complexity would be again O of n, right? Because we are using two stacks, right? And we are storing all the elements basically in the stack, right? So, but still, if you could see, but the worst case तो of any होगा, but if you could say what would be the strictly टाइम कंस्ट्रेंट ऑफ दिस कोड, तो आप देखोगे कि एट मैक्स हम मैक्सिमम विड्थ ऑफ द ट्री को ही स्टोर कर रहे हैं अपने में, मैक्सिमम विड्थ ऑफ द ट्री प्लस सेकंड मैक्स विड्थ ऑफ द ट्री, मतलब ये एंड ये लेवल, राइट? बट या if you're talking in O of terms, O terms, that is big O terms, the O of n would be this space, right? Now, this question can be solved again in the second way using another data structure, which is deck, right? Which has a privilege of popping and pulling out from both the sides, right? Basically, you can add and remove from both the sides, right? So here what we will do is, so in the current tree itself, let's say we have this deck here, right? And we first of all add our first element here, that is one here, right? And we will we will have one flag basically, let's say even level flag, right? And whenever we go to the, let's say, next level, that is the second level, 2 and 3, and we use the either sides of our deck to do the operation, right? Because that's where the privilege lies here. So for 2 and 3, what we're going to do is, हम प्रोसेस करना चाहते हैं तो हम चाहेंगे कि we have 3 first and then 2 uh, later on, so that we can add this order in our expected output, right? So we will push the elements in the last, like from the this side of the queue, which is set as, let's say, last, and this side front, or let's say first, whatever you call it, right? So we're gonna push it here, and we're gonna maintain the order. We want 3 first, right? So we're gonna push 2 first and then 3, so that when we pop it out, we get 3 first, right? So for the even level, let's say, what is the order we are maintaining? That we are pushing first the left children, right? And then the right children, right? Then definitely we can say that for the another odd levels, we need to maintain the order of right, comma left. Let us verify this as well. So we have one resultant array list. So we have first here, right? And then we pull out 3 from the other side. That is using the function called remove last, right? And we're gonna be then processing its children, that is 6 and 7, and we're going to use first right, that is we're going to process first 7, we add it to the first, and then we add 6 to the first, right? Then we pull out 2 from the last, and then we process the right children of 2, that is 5 first, and then 4, right? Now we again wish our even level, or let's say the flag variable, will reverse, and we will start pulling out from the front of the queue, right? So we'll be pulling out 4, 5, 6, and 7. So this, since there are no children to process, so we'll not add in the last for these corresponding nodes, and for the children of these corresponding nodes, right? And you can see that this is our expected output as well, right? I hope you got the intuition and the dry run and a complete understanding of this problem. Please try to pause this video and try to code this both approaches by yourself. Java language preference is yours. If you code in Java, do with Java. If you code in C++, do with C++. Now, what is the time complexity of method 2? It is again O of n, because we are processing each and every node, and O of n for storing the elements in the queue. So what is the difference between method 1 and method 2? Complexity wise, there is no difference. Just understanding wise, learning wise, we just explore two ways of writing the code using two different data structures, right? So please pause this video and try to code this approach. And this question also been listed on LeetCode as well, and the company tags are big. If you can see, it has been asked in Flipkart, Amazon, Microsoft, so basically the FANG level companies or product-based companies. So let the editor, oh, okay, my screen was not sure. Okay, so let me refresh the code and then we'll start the live code. Okay, as you can see, these are the big companies which has been asked the same question twice, thrice, and maybe I don't know how many times in the interview, right? So let's get started now. Okay, so I'm gonna start writing the code. So first we need two stacks. So I'm just making two stack, and then I'm pushing the first root node into our stack one. So s1 dot push root, right? And while either of our stacks is empty, we're gonna process this thing. So s1 dot is empty, or s2 dot is empty, right? Now, while our first stack is not empty, so you're gonna first empty its element and process the children. So for the S1, what we decided? We decided to push right and left. We're actually pulling out the elements from S1, right? Let me go back to the tab screen. We were pulling out the elements from S1 here, right? And we were adding in the S2. So the order we maintained was left, comma, right. So we're gonna do the same here. Hmm. So we'll be pulling out first of all the elements and we'll add it in our uh, this thing, resultant array list, right? So S1 dot pop and array list dot add. We will declare an array list and we'll add temp dot data. Correct? Now we're gonna process. So I'm gonna process the left and right child, and I'm gonna add it in our S2. So let me do that. All right, this makes sense. Now we're gonna do the same for our stack too. So let me copy this thing, and we're gonna pop it. We're gonna add it, and then instead of this thing left, it would be first. It would be first right and temp dot right, and we will be pushing an S1, right? Similarly, this would be left, left, and we're gonna be pushing it into S1. And this would be nothing but our S2, right? Make sense? Okay, and at last, while all the processing been done, that is either of our or both the list have been empty, both the stack basically have been empty, we will be returning an AL, that is an array list. So let's just declare an array list at the top. So AL is equals to new array list. Great. Let's compile and run, and we'll go on with the second approach, and we'll see the C++ reference as well. We are getting it clearly, so हमने एक गलती करी यहाँ पे not empty लिखना था, right? Okay, now we should not get it clearly here. I think एक infinite loop में ही फंस गया था ये, and then the whole time was exhaust for the compiler, by the compiler. Let us hit the submit button for this code, and we'll see a C++ reference for this. Okay, so that solution got submitted. That's great. Kudos to everyone who has solved it. And here goes our C++ reference, and I think you'll be able to relate it. So since many of you have asked to just give the reference of C++, so that is why I'm submitting this code as well. Okay, now let us try to code the second approach that was using the deck gear structure. Okay, so first things first. We're gonna making an array list, we're gonna making a deck, and we'll be adding the root node into our deck first, right? So the code is like this. So while deq matlab, deck is not empty, we're gonna first of all take the size of the current deck, right? Because at that many times we're gonna do the poll and process its children, and then we will toggle our flag variable, that is this even level. So while n is greater than zero, while n is greater than zero, and we're gonna check. So if even level, so definitely we are at this point, at the first time when this if will run, we will be processing a second level of our node, right? Which means this one. this one. First, we have pushed our this node into the deck, and then we are processing this one, right? So what we have decided, so we will be first pushing left and right for the even level nodes, and then we're gonna flag the variable, toggle the flag variable, and we're gonna push right and left. So remember this, and let's get started. So if it is even level, then just pop the current node. So that is node current is equals to nothing but eq dot remove remove first, right? And resultant dot add current dot data. So far, so good. So now we were actually processing first current dot left is not equals to null. Then we're gonna add it in the last of the queue, right? So eq dot add last current dot left, right? Similarly, we're gonna check now if current dot right is not equals to null. Then we're gonna add dq dot add last current dot right. So far, so good. Now we're gonna just copy the same code. We're gonna just change from left to right to right to left, and that goes in the else case. So, but in this case, we do not have to do from remove first. Instead, we have to do from remove last, right? Because once we have processed the first root node, that is one and two, and we add it in the add last, right? So So once we've added in the add last, then in the next iteration, we need to remove from the last itself, right? So that's why remove last, and which we have covered in the dry itself in a very deep manner. So current dot, we just need to change it now. So I think you can just write like this. If it is right, and I'm just gonna copy paste the code for left below it. But we do not have to add it in the last. We need to now add it in the first. So add first. And once this while loop is over, then and only then we need to toggle our flag. So I'm gonna say just toggle it, right? If it is true, make it false. If it is false, make it true. And after the final while loop, we're gonna return the result. So where is this ending? Okay, this is ending here. And after this while loop, I'm gonna return the result. That is it, yeah. That would be it. Let us compile and run. We'll wait for the submission, and I don't want to reset it. Okay, so there's some problem. Let me just quickly look at it. Hope you were able to find it as well. So we are declaring a while loop while is n greater than zero. So when this while loop gonna end, we have not specified the increment or the decrement operator. So once we have processed a node and do an n minus minus. So that would be it. Compiling and running. Okay. Now I'm gonna direct submit the code. Great, the tests have been starting to pass. And all the test cases have been passed successfully. Okay, so let us now see the C++ reference and we shall end this video. So there goes our C++ code, and I hope it will help the C++ users as well, just to target the wider audience. And because language should not be a barrier to understand the concepts. And that is why I spent so much time in explaining the driver and the intuition behind it. So that was it. And do not worry, you will get the source code link in the description, as well as this would be a frame of reference, because basically this is the format I maintain to push any code. So it has CPP code, the Java code, all the methods, and if the question has been asked on LeetCode, then definitely the LeetCode version code as well, and a readme.md where you can just click on this image and you will be
Okay, so
uh,
welcome.
welcome back everyone. You will be forwarded to the actual video, and you can study the problem in the readme.md as well. And that is the reason I'm asking or maybe requesting you to start and fork this repository, because it will be very handy and helpful for your interview preparation. And that is it for this one. And again, the lead code version would also be there in your source code. The logic and things remain same. So That is it for this one. Let us meet again in the next video on the next question. Till then, keep learning, keep bringing goodbye, and take care. If you're on this channel, please like, share, and subscribe, and let us meet again.